Light of different wavelengths or frequencies show up as different colors. The range of colors visible to us can be found in the electromagnetic spectrum. As you can see, the spectrum stretches from radio waves, which have a high wavelength and low frequency, to gamma rays, which have a low wavelength and high frequency. In between is the visible light spectrum, where red has the longest wavelength and shortest frequency, and violet has the shortest wavelength and the highest frequency in the visible range. Black and white are not actually colors by themselves, but combination of other colors. White is a combination of all colors, and black is an absence of all colors. When light hits the side of the prism, we notice a rainbow effect on the other side. This is because white light is composed of all the 7 colors, and when they are incident on one side of the prism, they deviate at different angles since each color has a different frequency. Red has the shortest frequency and hence deviates the least, whereas violet has the longest frequency and deviates the most. This gives a rainbow-like effect. In Newton's disk, each of the 7 colors are represented equally as a slice of the disk. When the disk is rotated very fast, eventually we see it as white. In Newton's disk, each of the 7 colors are represented equally as a slice of the disk. When the disk is rotated very fast, eventually we see it as white. If we pass white light through the first prism, it splits into the 7 distinct colors. Now, if we have a thin slit where only one of the colors can pass through, then only that color will be incident on the adjacent prism. It is noticed that the light emerging from the second prism is the same as the light that was incident on the second prism. This shows that the prism itself produces no light. If white light is incident on one face of the prism, it splits into 7 colors. Now, if those 7 colors are now incident on another prism, they recombine and emerge as white light. This proves that white is a combination of the 7 colors. A rainbow is normally seen in places where there is rainfall. The water droplets in the air act as prisms. White sunlight passing through the droplets refract in the droplet into the 7 colors which we see as the rainbow. Red is often used in danger signals as you need to be alarmed from a distance. Red color has a high wavelength and low frequency, and deviates the least as we saw in the prism. Since it deviates the least, it is ideal for danger signals, as other colors would be less visible after deviation. The colors red, blue and green are known as primary colors. When these 3 colors are added, we get white light. Secondary colors are obtained by combining two primary colors. Click on the torches to get the combination of primary colors. Red plus green gives yellow. Red plus blue gives magenta. And blue plus green gives cyan. When a primary color is added to a secondary color to give white light, they are known as complementary colors. For example, if primary color blue is added to a secondary color yellow, it gives white light. Remember that yellow is a combination of red and green. So effectively, you add the three primary colors to get white light. When a primary The color of a pigment is not actually the color of a pigment, but a combination of colors reflected by the pigment. For instance, if all three torches are on, then white light is incident on the surface. We see the surface as yellow, since it absorbs the blue and reflects green and white, which form the yellow color. By clicking on the torches, you will be able to experiment with a combination of colors. Color filters allow only its constituent colors to pass through. The rest of the colors incident on the filter are absorbed. For example, the magenta filter allows red and blue to pass through, as blue and red add up to magenta. Green is absorbed here. When a light wave is incident on an air molecule, it increases the vibration of the molecule and scatters light in all directions. When the size of the air molecule is smaller than the wavelength of the light wave, the intensity of the scattered violet light, which has a low wavelength, is much higher than the intensity of the red light, which has a high wavelength. When the size of the air molecule is larger than the wavelength of the light wave, the intensity of the light is the same for all wavelengths and appears white. Light has to travel a long way to get from the sun to the earth. The blue light, due to its short wavelength, gets scattered more than red light of a long wavelength. This scatter creates a blue color in the atmosphere, which makes the sky appear blue. At noon, the sun is directly overhead and is the shortest distance from the earth. There is not much scattering as light travels a shorter distance. Since the scattering is not much, the color of the sky appears white. When no atmosphere is present, there is no scattering of light, and hence the sky appears black. When you look at the sky from the moon, it appears black, as there is no atmosphere on the moon. When no atmosphere is present, there is no scattering of light, and hence the sky appears black. When you look at the sky from the moon, it appears black, as there is no atmosphere on the moon.